Most PySpark interview questions are not just about syntax anymore. Interviewers don't only ask, what is Spark or what is a data frame? They want to know whether you can handle real production problems. Duplicate events, bad files, slow joins, schema changes, retries, full reloads, and wrong outputs. So in this video, let's do a PySpark mock interview with 7 real production scenarios that every data engineer should understand. Hello everyone, welcome to Big Data Fact. I am Pranit and I have 4+ years of experience working as a data engineer. If this is your first time visiting this channel, don't forget to subscribe for more content on big data and real world insights. In this mock interview, I will first ask the questions like an interviewer, then I will explain how you should answer it in a real interview. So let's start this. Question 1. Interviewer asks, you are processing clickstream events in PySpark. Because of retries, the same event ID can appear multiple times. How will you remove the duplicates and keep the latest record? A weak answer is, I will use drop duplicates. That may work if you don't care which record is kept. But if the interviewer says, keep the latest record, then drop duplicates is not enough. Because it does not guarantee that the latest row is selected. A strong answer is, I would use a window function. I will partition by event ID, order by event time or ingestion time descending. Assign row number and keep only row number equal to 1. So the logic is, for every event ID, rank records from latest to oldest. Then keep the latest one. This shows that you understand production deduplication, not just syntax. What the interviewer is testing here is, can you handle duplicates events safely? Do you know the difference between simple deduplication and latest record selection? Question 2. Your PySpark job is reading JSON files from a source system. Some records are malformed and some fields are missing, and the job is failing. How will you handle this in production? A beginner may say, I will remove the bad records. But in production, you should not silently drop bad data. A better answer is, first, I would define an explicit schema instead of relying completely on schema interference. Then, I would read the files in a controlled way, handle malformed records using permissive mode or corrupt record handling, and separate bad records into a quarantine location. After that, I would validate important columns like event ID, user ID, and event time. If records fail validation, I would log them, store them separately, and monitor the count of bad records. The key point is, bad records should not break the whole pipeline, but they should also not disappear silently. What the interviewer is testing here is production safe ingestion and data quality mindset. Question 3. Interviewer asks, you have a huge transactions data frame and a small product dimension data frame. The join is slow. How would you optimize it? A strong answer is, first I will check whether the product dimension is small enough to broadcast. If it is small, I can use a broadcast join so Spark sends the small table to all executors and avoids a large shuffle. Before joining, I would also select only the required columns and apply filters early. For example, don't join 100 columns if you only need 5. Then I would check the physical plan using explain to confirm whether Spark is actually using broadcast join or not. But I would also mention the risk. Broadcast join helps only if the small table is small enough. If I broadcast a large table, it can create memory issues. So the answer is not just use broadcast. The answer is check table size, filter early, use broadcast join when appropriate, and verify the physical plan. That sounds like production thinking. Question 4. Interviewer asks, in your pipeline, the same transformed data frame is used for 3 different outputs. The job is recomputing the same logic again and again. What will you do here? The concept here is Spark lazy evaluation. If a data frame is reused across multiple actions, Spark may recompute the lineage multiple times. So a good answer is, if the data frame is expensive to compute and reuse multiple times, I would use cache or persist. But I would not cache everything blindly. I would cache only when the data frame is reused and the cost of recomputation is high. I would also trigger materialization using an action, and after the data frame is no longer needed, I would unpersist it to free memory. If memory is limited, I may choose a different storage level using persist. The interviewer is testing whether you understand lazy evaluation, recomputation, memory usage, and when caching helps versus when it hurts. The best line to remember is, Cache reused expensive data frames, not every data frame. Question 5. Interviewer asks, your PySpark job writes data to a target table. The job fails after writing some records. When the job retries, duplicate records are created. How will you make this pipeline retry safe? This is a real production issue. A weak pipeline only works when everything succeeds the first time. A production pipeline should be safe to rerun. So I would answer, I will avoid blind append for critical target tables. I will use a unique business key like order ID, event ID, or a combination of columns. Then I will use merge or upset logic so that if the same record comes again during retry, it updates or matches the existing record instead of creating duplicates. I would also design the job to be idempotent. That means if the same job runs once or twice, the final output should still be correct. Along with that, I would validate row counts, duplicate counts, and possibly reconcile source and target after the load. The interviewer is testing whether you understand idempotency, and this is one of the biggest differences between demo pipelines and production pipelines. Question 6. Interviewer asks, yesterday the source file has 10 columns. Today it had 12 columns, or one column type changed. Your PySpark pipeline starts failing. How will you handle schema changes? A good answer is, first, I would not blindly depend on schema interference in production. I would maintain an expected schema for important datasets. If new columns are added, I would check whether they are allowed and whether downstream systems need them. If a column type changes, I would treat that carefully because type changes can break transformations and reporting. I would add validation checks to detect schema drift early. Unexpected records or incompatible schema changes can be written to a quarantine path or failure location for review. If I am using a platform like Databricks Autoloader, I can use schema evaluation features but still with monitoring and control. The key point here is schema evaluation should be managed, not ignored. The interviewer is testing whether you understand that source systems change and production pipelines need to detect and handle those changes safely. Question 7. Interviewer asks, your table had billions of records. Currently, the PySpark job reloads and reprocesses the full table every day. How would you make it incremental? Good answer is, I would first identify a column that can help detect new or changed data. For example, updated date, created date, event time, or a commit version if available. Then I would process only the records that are new or changed since the last successful run. I would store the last processed watermark and in the next run read only data greater than that watermark. If the target table already has records, I would use merge or upset based on a unique key. If the source is a delta table, I may consider change data feed to capture inserts, updates, and deletes, but I would also keep a backfill strategy. Because sometimes we may need to reprocess old dates due to logic changes or late arriving data. The interviewer is testing whether you understand scalable pipeline design. Full reloads may work for small data, but at production scale, incremental processing becomes very important. So let's recap the 7 production PySpark scenarios. 1. For duplicate events, use window functions when you need to keep the latest record. 2. For bad JSON records, use schema control, corrupt record handling, quarantine paths, and validation. 3. For slow joins, think about broadcast joins, filtering early, selecting fewer columns, and check the physical path. 4. For reused data frames, cache or persist only when it actually helps. 5. For failed retries, make the pipeline idempotent using keys, merge, and validation. 6. For schema changes, detect schema drift and handle it safely. 7. For large tables, avoid full reloads and design incremental processing. These are the kinds of answers that show real data engineering experience, not just PySpark syntax. If this mock interview helped, comment PySpark and I will make a second part with more real production scenarios. Drop a like and subscribe to Big Data Factory. This is all for today. We'll meet you in the next video. Till then, keep learning and keep building. Bye bye.